Hello there, and welcome to Science for Sleep, where wonder takes its shoes off at the door and science speaks in a softer voice. Tonight we're going to rest our thoughts on something curious, something so close to us we hardly notice it, like the ticking of a watch worn for years or the rhythm of a heart beating gently beneath your hand. We're asking, is time real? Not what is time? No, not tonight. Tonight is slower than that. We're simply wondering if all these hours and minutes and days we live by are truly part of the universe, or just something we carry around inside us. And so before we tiptoe into tangled theories and ancient clocks, may I ask, what time is it where you are? Are you curled beneath blankets at midnight? Is the sun just beginning to stretch across your window? Funny, isn't it, that we're all here, right now, but that now feels different for every one of us. If you find this gentle wandering soothing, or if you've come here simply to soften the edges of a long day, it would mean the world if you tapped like or subscribed. It helps this little corner of quiet find others and grow just enough to keep the kettle warm. So settle in, slow your thoughts, and let's begin. Because somewhere between dreams and daylight, between seconds and centuries, lies a question older than memory. Is time real? Time doesn't just pass, it plays. It stretches, shrinks, loops, and sometimes disappears entirely, all depending on where your mind happens to be. You felt it. That strange elasticity of hours and minutes, the way a joyful afternoon slips through your fingers like silk while a silent elevator ride can make 30 seconds feel eternal. It's not the clocks that are tricking you, it's your brain. Because time, as we feel it, isn't measured in seconds, it's measured in experience. Let's take a quiet moment to unpack that. When you're bored, really properly bored, your mind becomes a little too good at noticing everything. The hum of a distant fridge, the twitch of a curtain, the little metronome in your head begins tapping out every second with excruciating clarity. And the more you look at the clock, the slower it seems to go. This is your brain starved for novelty. And in the absence of stimulation, it turns inward, scrutinizing time itself. Compare that to the flow state. When you're so immersed in something, you lose track of time completely. Not because it's sped up, but because you stopped counting. Psychologist Mihaly Csikszentmihalyi called this flow. It's a state of deep engagement where self-consciousness fades, and so does your sense of time. Your mind, busy painting, reading, coding, laughing, simply lets go of the ticking. In this sense, time is less like a clock on the wall and more like a spotlight, following wherever your attention goes. But attention isn't the only player in this performance. Emotion has a front row seat too. Fear, for instance, slows time. Ask anyone who's been in an accident or stood on the edge of something terrifying. In those moments, seconds feel like minutes, not because the world changes, but because you do. When you're afraid, your brain enters a high alert mode, recording details with extra intensity. Later, when you recall the moment, the sheer density of memory gives the illusion that time must have stretched. Your brain says, "This felt long. There's so much here," even if it was over in a blink. Joy, on the other hand, compresses time. We often say time flies when we're having fun, and it's true. Because when we're happy, we're less focused on measuring moments and more focused on being in them. This emotional lens shapes how we remember time too. A week of vacation can feel fast while it's happening, but looking back it seems long and full. Why? Because your brain had more to record. Novelty plays a key role here. New experiences create more memory anchors. They stand out. They slow things down, at least in hindsight. This is why childhood feels so expansive. Every day is bursting with newness. New tastes, new words, new fears, new games. Your brain is flooded with impressions, and so your memory of those years becomes thick, layered, full of detail. As adults, we fall into patterns. Wake, work, repeat. Fewer highlights, fewer memory bookmarks, and time quietly slips by. This phenomenon is sometimes called the reminiscence bump. It's the reason older adults often recall their teens and 20s more vividly than the decades that followed. Not because those years were objectively better, but because the brain was busier recording them. So in a strange way, we don't just live time, we construct it. And like all good construction projects, the outcome depends on tools and materials, your attention, your emotions, your novelty, your memory. But the illusion doesn't end with memories. There's another curious trick the brain plays, called the return trip effect. Have you noticed that the journey back from somewhere often feels shorter than the trip there, even though they take the exact same amount of time? It's not magic, it's expectation. On the way out, your brain is logging new information. New streets, new turns, new landmarks, even if they're dull. But on the return, there's nothing to learn. The brain already knows the route. It can coast. And so, even though the minutes are the same, you experience fewer of them. Less recording, less perceived time. This gap between clock time and felt time is something psychologists call subjective time perception. And it's not just a quirk, it's a defining part of consciousness. Even our body's natural rhythms contribute. We each carry a set of internal clocks, biological oscillators, that govern everything from hormone release to digestion, temperature and energy. These rhythms, especially the circadian one, don't just shape when we sleep. They shape how we feel time moving. That sluggish afternoon haze, that sudden midnight alertness. Those aren't just moods, they're temporal tuning curves, your body's way of keeping its own quiet beat. And here's a strange thought. Your brain doesn't even process now instantly. There's a delay, about half a second, between when something happens and when you become aware of it. But your brain edits out the lag. It stitches your senses together into a seamless present moment, a kind of real-time illusion. Like a film editor cutting out the gaps so you can follow the story. So the present isn't really present. It's a guess, a construction. Even language shapes time. In English, we talk about time as a resource. We spend it, save it, waste it. In Mandarin, speakers tend to talk about time as vertical. The future is down, the past is up. In Aymara, an indigenous language of the Andes, the past is in front of you, because it's known, and the future is behind you, out of sight. Isn't that wonderful? How deeply metaphor guides meaning. We don't just use time, we imagine it. We live in stories built from it. And maybe that's the clearest clue of all, because when we talk about time, we're really talking about change, and how we feel about that change. Excitement speeds things up, anxiety slows things down, age shortens the years, novelty lengthens the days. Time is not just a river flowing around us. It's a mirror reflecting how we engage with the world. And before we even ask whether time is real, physically, fundamentally, we must understand this. Time is first and foremost a feeling. It is emotion, memory, and story. It's not something you measure, it's something you carry. So the question, is time real, might begin not in the stars, but somewhere far closer, in the quiet space between your heartbeat and your next thought. Long before clocks ticked, before sand trickled through glass or bells tolled across rooftops, humans still lived with time, not measured, but felt. It rose with the sun, fell with the stars, whispered in the winds, and bloomed in the turning of seasons. To early humans, time wasn't something abstract. It was a rhythm, a breath the earth seemed to take again and again. The ancient Egyptians watched shadows fall across stone obelisks, dividing daylight into slender slices. To them, time came from the sky, written in light. The Babylonians, ever-watchful sky readers, mapped the heavens with extraordinary care, tracking planets, eclipses, lunar phases, not to measure time the way we do, but to make sense of fate. Time, to them, wasn't linear. It was circular, celestial, a wheel that turned endlessly, dragging human destiny behind it. In Hindu cosmology, time expands and contracts across incomprehensible scales, from the blink of a god's eye to the span of an entire universe. There are yugas, great cosmic ages, and each is born, thrives, and collapses in sequence, only to begin again. Here, time is not a straight line with a start and an end. It's a spiral, a breath, a dance with no final curtain. The Maya, without metal tools or telescopes, built calendar systems so precise they could track solar and lunar cycles across thousands of years. To them, time was sacred geometry, woven into ritual, architecture, and myth. Their long-count calendar marked not just dates but cycles of existence. The universe had beginnings and endings, but always in patterns, like music, not arithmetic. In Norse mythology, time was a tree, Yggdrasil, whose roots and branches held all the realms of being. The past, present and future were not separate paths but living layers woven together in the bark and branches of the world itself. And for the Greeks, time came in multiple flavours. There was Chronos, the ticking, measuring kind, steady, relentless, unyielding. But then there was Kairos, the right time, the opportune moment, when everything aligns and meaning unfolds like a flower. One is clock time, the other is soul time, and both, somehow, are real. In every culture, time has a texture. Some see it as a road stretching forward, straight, paved and purposeful. Others see it as a circle, an endless rhythm of return. In English, we say things like, time is money. We spend it, waste it, save it, or run out of it. Time becomes a kind of currency, a wallet we're always checking. But in other languages, the metaphors shift. In Mandarin Chinese, the word for next week literally translates to down week, and last week is up week. The future moves downward as though we're stepping into it. In Aymara, a language spoken in the Andes, the past is in front of you because you can see it, and the future, behind you, invisible, unknowable. It's the opposite of how many of us imagine time, and yet it makes a kind of emotional sense. After all, we know the past. We carry it in photographs, memories, wrinkles. It walks with us. But the future? We can't see where we're going. We can only feel its approach. Even the direction we imagine time flowing is shaped by how we write. In cultures where writing moves left to right, people tend to visualize time moving in that direction. Right is forward, left is back. But in right-to-left languages, like Arabic or Hebrew, time flows the other way. The arrow of time bends with the pen, and beyond language there are rituals, New Year's celebrations, harvest festivals, sunrise prayers, all moments where communities pause to mark the turning of invisible wheels. We light candles for the past. We make wishes for the future. We place meaning on something we can't touch. Even grief is a form of timekeeping. We measure loss in years, how long it's been, how it still feels. We say time heals, though sometimes it doesn't. Time is not just something we observe, it's something we honour, through birthdays, through anniversaries, through the soft ritual of saying, remember when. In this way, time becomes cultural, spiritual. It's not just a background to life, it is life, braided into language, painted into myth, marked in story and celebration. And maybe, long before science asked, what is time? Humanity was already whispering the better question. What does time mean to us? If you ask a physicist what time is, you may get a pause before you get an answer. Not because they don't know, but because they know too much. Because time is slippery. It feels simple, intuitive, we live in it, schedule by it, age through it. But when science tries to pin it down, time wriggles away, like mist through your fingers. Let's start not with Einstein or black holes, but with something closer to home. The tick of a clock. What is that tick? It's not just sound, it's a signal. 1 second passing, then another, then another. But underneath that second is a deeper truth, a rhythm, a regular, repeating motion. Ancient clocks used water, then pendulums, then quartz crystals, and now, deep underground and sealed away, we use atoms. The most accurate clocks today are atomic clocks, and they don't tick, they vibrate. A single cesium atom, when hit with just the right microwave frequency, will vibrate exactly 9,192,31,770 times per second. We decided as a species to call the rhythm a second. So in one way, time, at least measured time, is just a count of vibrations, a cosmic drumbeat we chose to follow. But that tells us how we measure time, not what it is. Here, physics splits into two worlds, the classical and the relativistic. In classical physics, Newton's world, time is absolute. It flows forward at the same rate, everywhere, for everyone. You could mark it with a stopwatch, or imagine it as a river, steady and constant, never bending. This made the math elegant, the universe predictable. Drop a ball, swing a pendulum, launch a cannon. You could calculate when and where it would land with beautiful precision. But even then, questions lingered. If time is constant, why does it feel so personal? If it's everywhere at once, why do we only see one slice? And then came Einstein. With special relativity, Einstein said, "Hold on, time isn't a river flowing past us. It's a dimension, a part of the fabric of reality, and it can bend." According to special relativity, the faster you move through space, the slower you move through time. That sounds like science fiction, but it's science fact. If you took a spaceship and flew near the speed of light, you would experience time more slowly than someone on Earth. A year for you might be decades here. This is called time dilation, and we've proven it. We've flown synchronized atomic clocks on planes, and when they land, the ones that flew showed slightly less time had passed than the ones that stayed on the ground. Tiny differences, nanoseconds, but still a measurable stretch in time itself. So suddenly, time isn't absolute. It's relative to speed, to movement, to the observer, and it doesn't stop there. Einstein's later theory, general relativity, added another twist, gravity. Mass bends space-time. The more massive something is, the more it warps the space and time around it. Imagine placing a bowling ball on a soft mattress. Now imagine placing a marble next to it. The marble will roll toward the dip, not because it's pulled directly, but because the surface itself is curved. That's how Einstein saw gravity. Not as a force pulling you in, but as the shape of space-time itself. And time in these warped zones runs differently. If you live near something incredibly massive, say, a black hole, time for you would tick more slowly than for someone far away. This isn't a metaphor, it's a measurement. Even here on Earth, 2 atomic clocks placed at different altitudes, say, one at sea level and one on a mountaintop, will tick at slightly different speeds. The one closer to Earth's core runs slower. This is called gravitational time dilation, and it's why GPS satellites orbiting high above Earth have their clocks constantly corrected, or else our maps would drift wildly out of sync. So time bends, it stretches, it warps with speed and weight. It is not the unchanging metronome Newton imagined. It is soft, responsive, a flexible weave stitched to the motion of matter. But even this picture isn't complete, because while Einstein gave us a curved universe, quantum physics, the theory of the very small, paints a different kind of mystery. We'll get there soon. But for now, let's linger a little longer in this strange new version of time, because what Einstein taught us is that time is not separate from space. Together they form a single fabric, space-time. This fabric isn't static. It shifts and trembles, curves and stretches based on the matter and energy it holds. It's like a living tapestry, woven with stars and galaxies, black holes and breath. And yes, you're not outside time, you're inside it, threaded through the weave, and so is everything else. Let's return for a moment to your body, because time doesn't just stretch between planets or tick from atomic clocks. It hums inside you, quietly, constantly. Every cell, every organ, even your sleep and hunger, is riding the rhythm of something called a circadian cycle. This biological timekeeper, nestled deep in your brain, syncs itself to light and dark, sunrise, sunset, and regulates nearly everything. Hormones, body temperature, alertness, digestion. In fact, if you were to live in a cave without daylight, your body would still keep some sense of time, but it would slowly drift. Because the rhythm isn't exactly 24 hours, it's closer to 24.2, and so we tether it to sunlight, resetting it every morning, anchoring our biology to the sky. This internal clock is ancient, not just in humans, but in plants, birds, insects, even certain bacteria. If it lives, it probably tells time, in its own way. And yet, none of these rhythms define time itself. They simply follow it. Like dancers tracing music they can feel but not explain. So what is the music? What exactly is time beneath all the ticking and timing? Here we find another strange thing. In many of the laws of physics, time doesn't care about direction. Whether you run the equations forward or backward, they still make sense. A ball thrown into the air and caught on the way down, rewind it, and the math holds up. A pair of particles colliding, play it backward. The formulas still smile. This time symmetry is everywhere in fundamental physics. So why, in real life, does time only move forward? Why do we remember yesterday but not tomorrow? Why do we grow older but never younger? To answer that, we turn to entropy. Entropy is a measure of disorder, how mixed up or spread out a system is. And there's a rule in thermodynamics. In a closed system, entropy tends to increase. In other words, the universe prefers mess. You can crack an egg, but you can't uncrack it. You can burn paper, but ashes don't spontaneously reassemble into books. These changes are not impossible. They're just unimaginably unlikely. And that's what gives us the arrow of time. Because while the laws of physics don't force time forward, entropy gently insists. It nudges everything toward disorder, and we ride that wave, from ordered beginnings to diffused scattered ends. It's not that time flows, it's that change accumulates in one direction, and we, being part of that change, feel it as moving forward. Entropy may be the only reason you remember your childhood but not your birth, why you dreamed about the future but never the past. In this way, time isn't just tied to clocks or gravity or motion, it's tied to possibility. And yet, we keep asking deeper questions, because if entropy gives us direction, and gravity gives us curvature, and speed gives us dilation, then what gives us now? What is this moment, this whisper-thin slice of time where everything happens? No law of physics explains it. The equations describe how states change, but not which one we experience. There is no formula that says, this is now. And so scientists have wondered, maybe now isn't a physical truth. Maybe it's a feature of consciousness. Maybe the present is not something the universe provides, but something the mind constructs. Like a theatre spotlight, our awareness moves through scenes one moment at a time, illuminating only the now as while all the other pages of the cosmic script remain in the dark. And then there's quantum physics, a field so strange, so unpredictable, that even time starts to feel more like suggestion than rule. But that's a story for later. For now, we can say this. Science gives us a time that is relative, curved, stretched, warped, emergent, entropic, vibrating, ticking, but never still. It is not one thing, but many. And yet somehow you live through it seamlessly. You feel it. You shape it. You name it. Time is not outside of you. It is braided into every breath, every choice, every heartbeat. Whatever it may be, you are part of it. Let's take a deeper breath. We're about to wander into the stranger corners of time, not just how it ticks or stretches, but how it behaves when no one is watching. We'll begin with mechanism, how time might emerge or unravel at the smallest scales of reality. A. Mechanism. Time and the quantum world. In the realm of quantum mechanics, where particles behave like waves and certainty becomes possibility, time becomes something curious. At this scale, there is no ticking clock, no sunrises or calendars, only probabilities, equations predicting where something might be or how it might behave if we choose to look. The foundational equation of quantum mechanics, the Schrödinger equation, describes how a system evolves over time. But strangely, time itself isn't treated as something physical. It's just there, an input, a silent background against which everything unfolds. It doesn't curve or stretch here. It doesn't participate. It just lets things happen. But then, something odd appears when you try to unite quantum mechanics with Einstein's general relativity. Suddenly, in certain models of the universe, time disappears altogether. The most famous of these is the Wheeler-DeWitt equation, a mathematical attempt to describe the whole universe as a single quantum system. And in this equation, there is no time variable at all. The universe, in its purest quantum description, seems to exist as a timeless whole, a vast collection of all possible states, no flow, no before or after, just an eternal, simultaneous everything. So where does our experience of flowing time come from? Some physicists suggest that time may be emergent, not fundamental, but something that arises when complexity and consciousness stitch together the right patterns. Much like temperature isn't a property of a single atom, but something that emerges from trillions moving together, time may arise when the universe becomes intricate enough to notice itself changing. In this view, time isn't ticking in the fabric of the universe. It's ticking in you, as your mind builds the illusion of past, present, and future from a sea of shifting relationships. This idea is poetic and unnerving. It suggests that time may not be real in the way we think it is. It may be a story, but a necessary one, because we need change to make sense, and stories require time. B. Implications, memory, perception, and identity. So what does it mean to live in a universe where time might be a narrative? It means that memory isn't just a recording device. It's your brain's way of building time itself. You remember the past because that's how your brain assembles continuity. Each memory is a link in the chain that tells you who you are, where you've been, why the next breath matters. Without memory, there is no sense of time, just isolated moments. Patients with certain neurological conditions, like advanced amnesia, often lose their ability to place themselves in time. They don't just forget names or dates, they forget now, they forget before and after. It's not just disorienting, it's existential. Without a sense of time, the self begins to fray. And so, time isn't just something we observe, it's something we become. The more complex the mind, the deeper the sense of time. Some researchers believe that our rich perception of time is what gives us identity, a kind of mental glue that binds the past and future to the self. That's why meditation, which temporarily suspends our focus on time, can feel so profound. When the ticking fades, when you're no longer waiting for the next moment, something loosens inside you. Some describe it as peace, others as a kind of floating. And in those moments, you glimpse what it might mean to live outside of time, not forever, just long enough to realize how much of it you usually carry. Let's now step into stranger waters, because time, as science understands it, doesn't always behave the way we expect, especially at the edges. See edge cases. Time at the limits. Start with black holes. These dense remnants of collapsed stars are famous not just for swallowing matter, but for stretching time itself. The closer you get to a black hole's event horizon, that invisible boundary where escape becomes impossible, the slower time moves, at least from an outside observer's perspective. If you were to fall toward the edge, someone watching from a distance would see you slow down, more and more, until you seemed frozen, suspended forever just before crossing. But from your point of view, you'd fall straight in what feels like a normal rush of seconds. Two observers, two wildly different clocks, both correct, and then there are neutron stars, so dense that a single teaspoon of their matter would weigh billions of tons. Near them, gravity also distorts time. Atomic clocks would tick measurably slower just a few kilometers from their surface than they would on Earth. Even at the edges of our own planet, we've measured these effects. Tiny, yes, but real. And what about the Big Bang? Our best understanding of the universe's beginning suggests that time itself began there. Not just matter and space, but time. Which leads to an unsettling question. What came before time? And the answer, perhaps, is silence. Because if time began with the Big Bang, then before may be a meaningless word. Like asking what's north of the North Pole. There is no before if time itself didn't exist. In this view, time isn't just something that passes, it's something that emerged with everything else. De-related phenomena, arrows, loops, and tangled threads. We've already touched on entropy, the great unraveller, and its role in pointing time in one direction. But that's just one of several arrows of time. There's also the psychological arrow. We remember the past, but not the future. The causal arrow, effects follow causes, not the other way around. The cosmological arrow, the universe is expanding, and as it stretches, so does our sense of forward. And intriguingly, all these arrows point in the same direction. Why? No one's entirely sure. Is it coincidence, causality, or some deep hidden symmetry of the universe? We don't know yet. But the fact that memory, entropy, expansion, and experience all align feels like more than chance. There are also theoretical loops. In certain solutions to Einstein's equations, you can have something called a closed time-like curve, a path through space-time that returns to its own past, a kind of cosmic roundabout. These loops don't break any math, but they raise every kind of philosophical problem. Because if you can return to the past, what's to stop you from changing it? Hence the grandfather paradox. Go back in time, prevent your grandfather from meeting your grandmother, and poof, you were never born. But if you were never born, how did you go back in time? Some physicists argue this is impossible, not just practically, but logically. Others propose ways around it. The Novikov self-consistency principle, for example, says that any actions taken by a time traveller were always part of history. You did go back, you did act, but nothing changed because your presence was already woven into the past. Then there's the many worlds interpretation from quantum mechanics, which sidesteps the paradox entirely. In this view, each possible outcome splits the universe into a new timeline. So if you go back and change something, you don't alter your original history when you create a new branch entirely. Each decision, each particle measurement, unfolds a multiverse of paths. No contradictions, just infinite variations. And while we haven't observed this splitting directly, the math holds, and the implications are dizzying. Because if true, there may be countless versions of you, some making tea right now, others never finding this moment at all. In some, time flows just as it does here. In others, who knows? But whether or not we can loop or branch or fold time, one thing remains certain. We live it. And in living it, we give it meaning. Because no matter how strange the math becomes, no matter how many clocks we build or paradoxes we ponder, time remains one of the most deeply felt truths we know, It marks our memories, shapes our hopes, and carries us, moment by moment, toward whatever comes next. Time may be invisible, but our attempts to track it have always been concrete. Stone, sand, metal, fire. Long before theories of relativity or atomic oscillations, humans measured time the same way they felt it, with rhythm, with repetition, a sunrise, a tide, a migrating bird returning to the same tree. These were the earliest calendars, drawn not on paper, but on the land and sky. Our ancestors were astronomers long before they were scientists. They learned the language of the heavens, not for curiosity but for survival. Plant too early and the frost would take you. Plant too late and hunger would follow. So they watched, they counted, and slowly time began to take shape. In ancient Egypt, tall obelisks cast long shadows, marking the hours as the sun arced overhead. These were the first public clocks. Sunlight split into segments, but the hours weren't fixed. They stretched and shrank with the seasons. A summer hour could be longer than a winter one. Time was still soft, elastic, tied to nature, not mechanics. Eventually we made water clocks, clepsydras, where time dripped out of bowls or flowed between vessels. They worked at night, which meant, for the first time, humans could count the darkness. In ancient China, engineers built intricate timepieces powered by falling water, gears and levers. Some even rang bells or turned miniature celestial globes. Timekeeping became art, but also power. To control the clock was to control the rhythm of a city, a court, a kingdom. By the medieval period in Europe, mechanical clocks appeared in towers, massive, clunky, and imprecise. They didn't even have faces yet. They rang bells to call monks to prayer, not to tell villagers the minute. Time was for God, not for business. But then, something shifted. As cities grew and trade routes stretched wider, a more precise time became necessary. Enter the pendulum. The year was 1656, and Dutch scientist Christian Huygens had a breakthrough. Inspired by the gentle swing of a chandelier in a cathedral, he developed the first pendulum clock accurate enough to lose only about a minute per day. Compared to earlier clocks, which could drift by hours, this was revolutionary. The pendulum brought discipline to time. It made it reliable, predictable, and suddenly the world could move with it. Commerce sharpened, schedules emerged, and with the ticking of the gears and hands came a quiet shift in how humans lived. Time was no longer seasonal or sacred. It became mechanical, portable, standardized. In the 18th and 19th centuries, as ships crossed oceans and empires expanded, precision in timekeeping became not just helpful, but vital. Sailors needed to know longitude, which required knowing the exact time at a fixed location, like Greenwich. So inventors raced to build accurate marine chronometers that could keep steady time even through storms and sea salt. One man, John Harrison, a self-taught English carpenter, devoted his life to solving this problem. His H4 clock eventually cracked the puzzle, earning admiration, and some envy, from scientists and kings. With accurate clocks, ships could navigate with certainty. But back on land, the trains were coming. As railways crisscrossed continents, it became painfully clear that each city running on its own local noon was a recipe for chaos. Imagine trying to plan a journey when every town is 5 minutes off from the next. So in the late 1800s, standard time zones were created, first reluctantly, then globally. Now time was coordinated, sliced into neat wedges of longitude, a shared rhythm across nations. But as the 20th century dawned, so did a radical new idea, one that would upend all the clocks we thought we understood. In 1905, a young patent clerk named Albert Einstein published a paper on what he called special relativity, and in it he proposed something extraordinary, that time is not fixed, that it changes depending on how fast you're moving, that there is no universal now shared by everyone, everywhere, He followed this with general relativity in 1915, revealing that gravity too affects the passage of time. Mass bends space, and with it bends time. And so, we arrived at a universe where time is not a separate backdrop but a living fabric, intertwined with space, influenced by matter, and always relative. Suddenly, all those precise clocks we'd spent centuries building needed a new kind of accuracy, which brings us to quartz. In the 1920s, engineers discovered that when you apply voltage to a quartz crystal, it vibrates at a stable frequency. That vibration, like a microscopic pendulum, could be used to mark time more accurately than anything before. Quartz watches became cheap, portable, and astonishingly precise. No winding required, just a little hum from within. But even quartz had limits, and so, in the mid-20th century we went deeper still, to the atomic. Today's atomic clocks measure the oscillations of atoms, usually cesium or rubidium, which vibrate at frequencies so stable they barely drift a second in millions of years. In fact, the modern definition of a second is now based on one specific number, 9,992,370 cycles of a cesium atom's radiation. That's not a guess. It's the official standard used to synchronize satellites, coordinate internet servers, and run the digital veins of the modern world. Your phone's map, your bank transactions, your airplane's navigation. All of them rely on the precise dance of atoms measuring time. We've come a long way from obelisks and dripping bowls, but for all our advances, the question remains, what are we actually measuring? Is it a property of the universe, a rhythm of the mind, a trick of entropy and motion? We've made time measurable, we've made it portable, but we haven't yet made it simple, because the closer we look, the more time begins to vanish. Let's pause for a moment. We've travelled through black holes, quantum probabilities, ticking atoms, ancient clocks. We've watched time bend, slow, and skip. And yet, for something so precise, so carefully defined, time remains profoundly unclear. Even the greatest minds, Einstein, Hawking, Gödel, Augustine, struggle to answer a question that feels almost childlike in its simplicity. Is time real, or is it something we made up? A kind of story stitched across change. In ancient philosophy, this question was already alive. St. Augustine, in the 4th century, wrote, "What then is time? If no one asks me, I know, but if I try to explain it, I do not know." He sensed what so many feel, that time is obvious and impossible at once. We feel it move, but when we reach for it, it slips between our thoughts. Some philosophers argue that only the present is real, that the past no longer exists, and the future hasn't happened yet. Only now is true. This view is called presentism. It feels right, doesn't it? We experience life moment to moment. We can't touch yesterday. We can't stand inside tomorrow. But there's another view, one inspired by Einstein's relativity, called eternalism. In this model, past, present, and future all exist equally. Time doesn't flow. It is a 4-dimensional landscape. You don't travel through time. You're simply located at one point in a vast temporal terrain. Just as every place on a map exists simultaneously, so do all moments in time. You're a thread running through a cosmic quilt, woven from every moment you've ever been and every one you will be. It's a radical idea, comforting perhaps, unsettling too. Because if the future already exists, what happens to free will? What happens to choice? Are we walking a path we chose or following one already paved? Some thinkers argue that time's flow is an illusion, a feature of how the brain processes change. We live in motion, so we assume motion is real. But what if now is simply the brain aligning memory, sensation, and anticipation into a coherent experience? What if the past still exists and the future already waits? Let's wander gently into another idea. What if time isn't something that is, but something that becomes? Some physicists propose that time is emergent, not a fundamental ingredient of reality, but something that arises from more basic relationships. Think of temperature. A single molecule has no warmth, but trillions of them moving together, that movement becomes heat. In the same way, perhaps time doesn't exist at the level of individual particles, but appears when systems become complex enough to have change, memory, and causation. In this view, time is the echo of complexity, a melody created by the motion of the cosmos as it listens to itself. Some theories even suggest that time may be a product of entanglement, that quantum systems interacting with each other generate a kind of internal time by becoming more intertwined, each moment a knot pulled tighter, each observation a branching of possibility. And speaking of branching, there is the many worlds interpretation, a view where every possible outcome of every quantum event actually happens, splitting reality into countless parallel timelines. In this universe, there's a version of you still reading these words, another that paused, one who never found this moment, and one just beginning again. In such a cosmos, time doesn't just move forward, it sprawls. Every tick of a clock spawns a new world, not a single thread, but an ever-branching tree of shimmering nows. And then there are those who say, maybe time isn't even a thing, not a force, not a flow, not even a fabric. Just a word we use to describe the way things aren't the same anymore. Change happens, so we name the difference, before and after. But perhaps the universe doesn't feel the difference. Perhaps only we do. Because we are memory-bearing creatures. Because we dream. Because we die. And death too is part of why time feels real. If nothing ended, why would we measure anything? Why would we cling to moments, mark anniversaries, collect photographs, whisper, remember when? Time may not be a substance, but it is surely a meaning. We love because time moves. We regret because it doesn't wait. We hope because it hasn't happened yet. And whether time is a dimension or an illusion, a fabric or a feeling, a ripple in quantum foam or a flicker of mind, we live by it. We ache with it. We make stories out of it. Perhaps that's enough. Perhaps the truth of time is not whether it's real, but whether it matters. And it does. Oh, it does. Time isn't just something we think about. It's something we live inside. From the moment we open our eyes, time is there, nudging us awake, reminding us when to eat, when to leave, when to rest. We wear it on our wrists. We hang it on our walls. We tap it onto our phones every few minutes as if to ask, am I where I should be? Yet, our days are carved into hours, our hours into tasks, our tasks into alarms and reminders, and little digital nudges that say, now, now, now. And yet, even amid all this structure, time often feels like something we can't hold. We run out of it, we lose track of it, we wish we had more of it, or just as often we beg it to go faster. Time in daily life becomes a kind of currency, but one that can't be earned back. We say things like, I wasted the whole afternoon. This week flew by. Where did the time go? We apologise for being late, pride ourselves on being early, and yet rarely feel like we're on time, not just by the clock, but in life. And still, we keep measuring. We track productivity in hours. We measure age in years. We celebrate birthdays, anniversaries, retirements, as if saying to time, I see you, I've noticed, please be kind. There's a quiet kind of magic in these human rituals. They're more than dates. They're moments we choose to name, to hold, to wrap in meaning. Because without them, life becomes a blur. There's something strange that happens as we age. When we're young, a single summer feels like a lifetime. The days are wide, the weeks endless, and the future a far horizon. But as we grow older, years begin to shrink. Holidays arrive sooner, decades blur together. This isn't just nostalgia, it's neurology. You see, the brain logs novelty with greater detail. When everything is new, first friendships, first heartbreaks, first places, the mind pays closer attention. More attention means more memory, and more memory means more felt time. But with routine, the brain grows efficient. Fewer mental bookmarks, shorter memory reels. That's why yesterday's commute feels like it vanished, but a childhood vacation lives in vibrant detail. We aren't imagining the speed up. We're just remembering less of the middle. And so, in daily life, time isn't just what the clock tells us, it's what the brain remembers. Even language reflects this. We say time flies, time drags, time gets away from us. We kill time, we keep time, we find time, we lose time. No other abstract concept has quite as many metaphors. In poetry, time is a thief. In business, it's a resource. In grief, it's a slow healer. In love, it's a window that opens or closes. Culturally, we assign meaning to different hours of the day. Mornings are for productivity, afternoons for meetings, evenings for meals and unwinding. Midnight, for some, is mystery, creativity, or just a second cup of tea in a quiet house. We build entire identities around when we feel most alive. Are you a morning lark or a night owl? Or perhaps something in between, a time-shifting pigeon just trying to stay awake? And then there are our rituals, the ways we honour time's passage, a toast at midnight, a candle on a cake, a moment of silence, a photograph framed and dusted. These little acts are our way of marking something we cannot touch. Time, after all, leaves no fingerprints, only memories, only stories. So we create ceremonies to catch it, to say, this mattered, this happened, this was real. And maybe in the end that's how time truly lives in us, not in seconds or schedules, but in meaning, in the things we choose to pause for, the moments we replay, the hours we hold on to long after they've passed. Let's pretend for a moment. Let's say you woke up tomorrow and everything was running backward. The tea you just swallowed rises back into the cup. Your shoelaces unlace themselves. Conversations rewind. Words unspoken mid-air. And time, it's not marching forward anymore, it's unravelling. Would the world still make sense? Strangely, in physics it might. Many of the equations that govern particles, forces and waves work just as well in reverse. Time in those mathematical spaces is symmetrical. Run the universe forward, it behaves. Run it backward, it still behaves. But here, in our world of scrambled eggs and faded photographs, that reversal feels impossible. Because we remember. Because things change. Because time feels like it flows. So let's imagine something else. Can we travel through time? It's a question that's launched 1,000 novels, bent 1,000 theories, and sparked more late-night debates than we can count. And surprisingly, the answer, at least for the future, is yes. Thanks to Einstein's special relativity, we know that moving very fast, just close to the speed of light, slows down time for the traveller. Fly around space at near-light speeds for a year, and when you return to Earth, decades may have passed. It isn't science fiction, it's been tested. Astronauts who've spent time aboard the International Space Station have aged ever so slightly less than we have on the ground. Tiny differences, yes, but real. This kind of time travel into the future is already happening, just not with DeLoreans or blue police boxes. But what about the past? That's trickier. According to general relativity, there are exotic conditions under which time might loop, places called closed time-like curves. If the universe is bent just right, with enough mass or a rotating black hole, it might be possible to return to an earlier point on your own timeline. And then, paradox. Imagine this. You build a time machine. You go back to before you were born and accidentally prevent your grandparents from ever meeting. And suddenly, you're never born. Which means you never went back. Which means they did meet. Which means you were born again. round and round. This is the classic grandfather paradox, and it sits like a puzzle cube in the heart of time travel theory. There are a few ways scientists and storytellers try to untangle it. The first is called the Novikov self-consistency principle. It suggests that if time travel to the past is possible, then the universe won't allow you to create contradictions. You can go back, but anything you do will already be part of history. Try to change it, and something will stop you. The gun jams, the letter never arrives, the banana peel gets you first. In this version, the timeline is fixed, immutable. You're not rewriting history, you're fulfilling it. Then there's the many worlds interpretation. This view says, go ahead, change the past. But when you do, you split reality. You don't alter your own history. You create a new branch of the universe, a parallel timeline where your choices ripple out in a different direction. No paradox, just divergence. And somewhere, in another version of reality, you're still sipping tea in the original timeline, none the wiser. These branching models have their own beauty and their own loneliness. Because if every choice splits the universe, if every decision unfolds another you, then somewhere out there are versions of your life you'll never see. One where you turned left, one where you stayed, one where the message arrived on time. Is it comforting or haunting? We don't know yet, because no time traveller has ever walked out of a machine and said hello, at least not that we can prove. Some scientists suggest that time travel to the past may be theoretically possible, but forever practically unreachable. We don't have the energy, we don't have the technology, and maybe we never will. Or maybe, if it's ever invented, it can't take you back to a time before the machine existed. No visiting dinosaurs, no ancient temples, only a slow leak of visitors from the future once the door has finally been opened. And yet, we keep dreaming about it. We write about it. We build stories, not just about moving through time, but about changing it. Why? Maybe because the real desire isn't for time travel. It's for second chances, to go back and say something different, to fix the mistake, to take the other path, to hold the hand just a little longer, and even if physics says no, our imagination says maybe. Maybe we can't change time, but we can remember, we can imagine, we can choose, right now, what kind of future we want to shape. In the end, that's its own kind of time travel, or a quiet act of hope, suspended inside a very real present. So here we are, a little farther along your timeline than when we began. We've drifted through ticking clocks and timeless quantum states, followed ancient shadows across stone, stood at the edge of black holes, and stepped lightly around paradoxes and possibility. And still the question hums softly in the air. Is time real? Perhaps. It depends what you mean by real. If real means something you can hold, then time resists you. It's not a thing. It's not a particle or a force. You can't pour it into a jar or store it in a box. But if real means something that shapes your life, then time is everywhere, in your breath, in your memory, in the way you know you're not the same as you were yesterday. Maybe time isn't a river. Maybe it's a mirror, reflecting who you were, who you are, and who you're becoming. Or maybe it's a garden, where each moment is a seed, and what grows depends not on the clock, but on your care. We talk about time as something we spend, as if we were losing it. But maybe we're not spending time. Maybe we're shaping it. Every conversation, every quiet choice, every pause between the things we meant to say. You see, time may not be a substance, but it's still a space where life unfolds, and we, curious creatures that we are, have been measuring that unfolding since the very beginning. We put lines on calendars, we count birthdays and light candles. We ask how long things will take. We wonder how long we have left, and through it all we keep trying to understand what it means that everything changes. Perhaps time is not a line, but a kind of music, You don't hold a song, you move with it. You remember its melody, anticipate its next note, but you never ask it to stand still. Maybe that's what we're doing here, listening to the rhythm of days and decades, of memories returning, of possibilities opening. Time, for all its mystery, gives shape to everything we love. The firsts, the lasts, the moments in between. It is because time passes that we value presence, that we savour voices, that we say I miss you and mean something deeper than distance. If the stars are scattered like dust across the cosmos, then time is what lets us notice them, trace them, tell stories from them. And while we may never fully grasp what time is, we can still feel what it means. A hand held longer than expected, a breath taken before speaking, a morning that stays with you, even after the day has gone. Time may be slippery, but you're not lost in it. You're part of it. Every second you've lived, every choice you've made, every version of you that has ever smiled or wept or grown, they're all still here, woven into the fabric of what you call your life. And maybe that's enough. Maybe we don't need to solve time to honour it. Maybe we just need to pause now and then and say, this moment, this one, is mine. So, where are you now? What time is it where you are? Not the number on a clock, but the kind of time you're in. Is it a time of stillness, of change, of drifting gently between days? Whatever it is, you made it here, and for that, thank you. Thank you for letting this voice be with you, across minutes or miles, in wakefulness or sleep. If this gave you peace, if it quieted the hum just a little, then I'm grateful. And if you ever feel like coming back, this time, this space will be waiting for you. So until then, rest well, sleep deeply, and remember, you're not behind. You're not too late. You're right on time. Sleep well, fellow traveller, wherever and whenever you are.